Hello and welcome. Are you somebody looking to achieve one of the very highest grades in GCSE Maths? Well, if you are, then please keep watching this, our third video in a series of 3 that aims to answer our most frequently asked question of all. What is it that you need to do to achieve a grade 9? Well, the first video aimed to answer that exact question and introduce this concept of conceptual thinking. The second video was how do we attack a GCSE problem? In other words, how do we extract the information we need from a question in order to answer it both accurately and efficiently? And then this video aims to give you a grade 9 exam toolkit. As we did previously, we've taken that one stage further and we've broken that question down into what we consider to be 6 bullet points that best address the question at hand. So the first bullet point is understanding GCSE command words. In other words, are we actually answering the question that's being asked of us? Secondly, are we showing sufficient working? The most able mathematicians, sometimes they don't avoid that temptation just to write the answer. But in order to achieve the full marks on offer for each question, we've got to show our working out. Thirdly, if diagrams are offered to us, are we using them effectively? Or indeed, are we drawing our own diagrams to help us understand a problem? Are we in a position to check our answers for suitability and accuracy? All very important skills. Next, when we're in an exam, there is no doubt we will be under time pressures. So are we using the most efficient method available to us? And lastly, as I mentioned in video 1 and video 2, certainly when it comes to the topic of proof, are we writing our explanations mathematically in order to achieve the marks on offer? So please continue watching if you are somebody looking to achieve one of the very highest grades in GCSE mathematics. Now, as we've done in the previous 2 videos, we've created 10 or 11 questions that not only aim to address each of these bullet points, but also aim to span the grades from grade 7 to grade 9. So let's get started. We'll begin, obviously, with question 1. And this first set of questions is looking at grade 7 onwards, exam technique, but more specifically, looking at the command words. In other words, are we answering the question at hand? So this first question, a circle has radius 7 centimeters, calculate the circumference of the circle. Well, there are 2 formulae for circumference. C equals pi d, or C equals 2 pi r. Now, I said there are 2 formulae. In actual fact, I would argue these are exactly the same formulae, because 2r gives us the diameter of a circle. It's just using the formula that links to that question that you're presented with so that you're working efficiently. Now, by that, what I mean is in this question, we've been given the radius, so it makes sense to use the formula that involves radius. So in this case, we'll have C equals 2 times pi times 7. C equals 14 pi centimetres. Now, at higher tier, when we're looking for those highest grades, we quite often encourage people to leave their answer as a fraction or a surd or in terms of pi. But in this instance, reading the question carefully, you will notice that we're being asked to give our answer to 1 decimal place. So using your calculator, and I'd always recommend people to become really familiar with using their calculator, let's just simply type in 14 times pi, execute, and you'll note that you may well have to change the format of your answer. Now I'm not going to write out the whole answer obviously, but I'm getting 43.98. Yes, there are other numbers on the end there, but I only need these first 2 because our question's asking us to give the answer to 1 decimal place. So in this case, our answer is 44.0 centimetres. And we must include this 0, otherwise our answer is not to 1 decimal place. The second question, our command words are show that. So in this case, we're not actually looking for an exact answer. We're trying to show that something is the case. The question says we've got a rectangle. So I mentioned initially, when possible, use a diagram to help your understanding. We're told that the rectangle has length x plus 4 and width x plus 2. And we're being asked to show that the area can be written as x squared plus 6x plus 8. Now the area of a rectangle, we should all know, is length times width. So in this particular case, the area will be x plus 4 multiplied by x plus 2. I'm going to show each step of my working out so that I get all of the marks on offer. I'll get x squared plus 2x plus 4x plus 8. If I then collect the like terms, I will get x squared add 6x add 8. And that matches what we were asked to show. I don't need to go any further. So if we look at question 3, and this time our command word is estimate. So we're not looking for an exact answer. We must do what the question says. But once I've done what the question says, we are asked to explain the approximations that I've made, or we've made. Well, 19.8, I'm going to call 20. 5.04, I will count as 5. And 2.03, I will call 2. So that actually gives us 100 divided by 2, which equals 50. So that's my approximation. Explain the approximations that you have made. I have approximated each number to the nearest whole number. And please include that short sentence in an exam so that you're answering the question. In question 4, the command word is explain. Now a student says, if two angles in a triangle are equal, the triangle must be equilateral. Explain why the student is incorrect. Well, I think a key word here is isosceles. So an isosceles triangle has two equal angles. The third ensures the sum is 180 degrees. And then I'm going to give an example. Now you can give any example you like. I'm just going to choose the example 50 degrees, 50 degrees. So then our third angle must be 80 degrees. So again, I'm explaining as fully as possible. to make sure I get the marks available. Now, questions 5 to 8 move on from that grade 7 plus more into the grade 8 territory. And we're looking for the correct application. In other words, the correct representation. So what do we have? We have a garden that's made from a rectangle and a semicircle. So I'm just going to do my best to draw that semicircle freehand. And we're told the length of the rectangle is 12 meters and the width is 8 meters. The semicircle has a diameter of 8 meters. So I've drawn my semicircle in the correct position. Find the total area of the garden, but give your answer to 1 decimal place. Well, I'm going to break this down into 2 parts. I'm going to do the area of my rectangle first. That will simply be 12 times 8, and that equals 96 square meters. I'm now going to do my semicircle. So I need to do pi times the radius squared, that will be 4 squared, and then divide by 2. 4 squared is 16, half of 16 is 8, so that will give me 8 pi square meters. And what's that equivalent to? Because remember, we need this answer to 1 decimal place. So I'll take my calculator, 8 times pi, change the format of my answer to get a decimal, and to 1 decimal place, that's 25.1 square meters. So the total area will be 96 plus 25.1, and that equals 121.1 square meters. So I'm using the diagram just to help my understanding of the problem at hand. In question 6, we're checking reasonableness. In other words, so can we estimate, is our solution, like it says, reasonable? Well, I'm going to round off my starting numbers to the nearest 10. So 398 will become 400. 62 will become 60. So that will give me an answer of 24,000. 24,000 and 24,676, they're pretty reasonable. But let's take it one stage further. If we take the last digit in each of our starting numbers, in other words, 8 times 2, well, that equals 16. If you take the last digit of that answer, it must match the last digit of our actual answer. 6 matches 6. So I would suggest part I, rounding to the nearest 10, is approximately 24,000. And secondly, 8 times 2 equals 16. So our answer must end in A6. So yes, I would suggest that is a reasonable answer. Let's look at question 7. We're working backwards this time. A number So before I go too further on, I'm just going to picture, I'm going to visualize what we mean. A number, let's call it x, is increased by 30%. By using the multiply method, if you increase anything by 30%, we must multiply by 1.3. And we're told that the answer is 91. Find the original number. Well, the inverse of times 1.3 is divide 1.3. X equals 70. Explain your method. I have used the multiply method and reverse percentages. Remember, not only do you have this series of 3 videos, which is aiming to answer that question of what do I need to do to get the very highest grade in GCSE mathematics, but there is also a series of videos available whereby you can watch topic-specific help. So if you're not sure on reverse percentages, please check out the reverse percentages video. So question 8, exam strategy. Are we working efficiently? A triangle has 9 sides, 9, 12 and 15 centimetres. The question asks for an angle. A student immediately uses the sine rule. Well, when using the sine rule for an angle, let's just remind ourselves of the sine rule. Sine A over A equals sine B over B, which equals sine C over C. And more often than not, we only ever use 2 aspects of the sine rule. But no matter which, in order to use the sine rule to find an angle, you must already know one of the angles. So explain why this method might not be the best first method. I would write, this might not be the best first method because we do not know any of the angles. Let's move on to question 9. And we're now starting to look at more grade 9 specific content and with a particular focus on reasoning. A swimming pool is being filled. The pool is a cuboid measuring 8 by 5 by 1.5 meters. Water enters at a rate of 40 litres per minute. The pool is initially empty. A student starts by calculating the surface area. Explain why this is the wrong approach, but then solve the problem. Well, the first thing I would say, this is a volume and capacity question, not surface area. Now, the next thing to take into account is the fact that we've got various units. So the first thing I'm going to state is that 1,000 cubic centimetres is 1 litre. but these measurements are given in meters. So to work out the volume of the swimming pool, I'm just going to convert everything to centimeters. So that will give us 800 times 500 times 150. We're looking at some rather large numbers there. So you don't get bonus marks for trying to do things in your head. Make use of your calculator if you need to. So the volume of our swimming pool is 60 million cubic centimeters. But we need to convert that to litres. So I need to divide by 1,000. 60 million divided by 1,000 equals 60,000 litres. To work out how many minutes that will be, will give us 60,000 divided by 40. And again, we can take our calculator, 60,000 divided by 40, and that gives us 1,500 minutes. Now, we're not asked to give this answer in terms of hours, but I just think it'd be a more reasonable answer. So to convert minutes to hours, we just simply divide by 60. "25 hours." So just over 1 day and 1 hour to fill a swimming pool from scratch. Let's scroll down. Can we justify our solutions? Let's have a read. A student solves x squared equals 49. As ever, I like to write down the problem for myself. And writes x equals 7. Explain why this answer is incomplete. Well, the inverse of squared is square root. Now, when you find the square root of a positive number, please remember, if you're one of those people looking for one of the highest grades, it's not simply 7. Calculators might suggest it is, but you need to remember that when taking the square root of a positive number, we have the positive and the negative solution. A negative times a negative is a positive, I'm sure is something you have heard. So the complete solution is plus or minus 7. Explain why this answer is complete. The student only took the positive root of 49. We needed that negative root as well. Now to finish, as we did in video 1 and video 2, we like to finish with a more challenging question. So let's have a read. A rectangle has whole number dimensions. Its perimeter is 40 centimeters. A student wants to maximize the area. They test 1 times 19. Now you'll note though those combinations of numbers add up to 20, and that's because if the whole perimeter is 40, half the perimeter must add up to 20. I suppose we could carry on. So here we could have 4 times 16. If I just work out the areas, we have 19, we have 36, we have 51, and we'd have 64. But we are categorically told we are not to test every possibility. Explain how you know which dimension gives the greatest possible area. Well, you may or may not know this, but a square is a special type of rectangle whereby each of the sides is obviously the same length. But not just that, actually a square, if you know the perimeter, always maximizes the area. So if we take our perimeter, which is 40, we can divide that by 4. Gives us a nice answer. If we were to take that perimeter of 40 and create a square, we'd have side length 10. So the maximum area would be 10 times 10, which equals 100 square centimetres. A square maximises the area of a rectangle if we know the perimeter. So there we have it. We have a series of questions that aim to build the toolkit that we think needs to be inbuilt in people if they are going to achieve the very highest grades in GCSE Maths. And actually we can take that one stage further. We believe the best habits to develop for those of you hoping to get that grade 9 are the following. What is the final thing I need to find? In other words, answer the question. What information is useful? In other words, does a diagram help? What information is a distraction? Is there any information there that doesn't really help with the question? And then lastly, does a diagram, does an equation, or might even a table help you solve the problem? Thank you for watching this, the third video in our initial series of 3. But don't forget, you can always tune in to our topic-specific videos if you are somebody looking to achieve the very highest grade in GCSE mathematics. Thank you very much.